In this slideshow, we're going to go over an introduction to what is statistics. Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting numerical data to assist in making more effective decisions. Notice when I read that definition that there are words that end in ing: collecting, organizing, presenting, analyzing, and interpreting numerical data. So that's five ing words. So there's five different things or different aspects of statistics. So we're going to spend the first part of the trimester talking about collecting, organizing, and presenting data. We'll cover that in the first couple of chapters. And then later on in this trimester, we'll talk about analyzing and interpreting data. If you look at this list, it's a list of ages, and you'll notice that there's no order to the ages. If I look at this list, I really can't tell anything about it. It's just a random lot of numbers. And here's the same data set continued. Again, I really can't make any conclusions about this just because it's just what we call raw data. In this slide, we see the same information, but in this case, it has been summarized. So the previous two slides where we had the list of numbers, that's where the data was collected. Okay, so that was collecting. And now you see on this slide where the information has been organized, and it's been organized into categories. And so we know from that data set, if we counted the number of individuals or observations from 20 up to 30, there were 3. There were 6 observations between 30 and 40. Just for your future purposes, this that you see on the screen is called a frequency distribution because it lists the groups or the classes, and then it indicates the number of observations or the frequencies in the right column. We call this a frequency distribution. So previous slides, the data was just collected. On this slide, it has been organized and presented. In more common usage, you hear about statistics all the time. For example, and you can see this on the screen, someone might say, what is the class average on a test? That would be a statistic. If you say, what was the highest grade on the test? That's a statistic. If you ask me how many people usually make an A in the class, that's a statistic. So the examples are the average starting salary of college graduates, that's an example, or if you wanted to know the number of deaths due to alcoholism last year, and so on, all of those would be statistics. And you'll notice the last example would be on the screen is the number of home runs hit by the Chicago Cubs during the 2007 season. That would be an area where there's lots of statistics. You know, in sports, there's plenty of statistics. So often statistical information is presented in a graphical display so that you can uh, sort of make interpretations or conclusions about the information. If we're looking at this screen, we see that statistics, again, is the science of collecting, organizing, presenting, analyzing, and interpreting data to make more effective decisions. And there's some formal tools that you can use for analyzing and interpreting statistical data that we will talk about in the later part of the trimester. So some of the decisions that you could be making in statistics, just look at some of the examples on the screen. A research analyst for Merrill Lynch may want to evaluate many facets of a stock before making a buy or sell recommendation, so they would use statistics to make those decisions. Or Colgate Palmolive would want to make recommendations regarding the potential profitability of a newly developed group of face soaps having fruit smells. Again, that would require some statistics or some research to go along with that. So that would be something or a situation where you would use. Here's some examples of some statistics. This is number of firearms death rate per 100,000 listed by state. And if you look at this information, it's from 2002. It looks like the state that has the most firearm deaths per 100,000 would be District of Columbia, and so on. And so this information that you see here for your future purposes is called a bar chart. What's nice about a bar chart is that we can see the relative sizes from comparing one group to another. So when you look at this, you see that big long bar for District of Columbia, and then the one for Alaska is a little bit shorter. But if you look at, let's say, number 8, 9, and 10, they're just about the same. Our eyeball cannot hardly tell the difference between the 16.6 and the 16.3 and the 16.2. Here's another set of statistics like land area by state. That's a statistic. And you will notice that they are rank ordered from 1 to 10. Alaska has the most land area. And if you look at the size of that bar in the bar graph, it is much larger than Texas, which is the second largest state. But again, looking on numbers, let's just say 9 and 10, it's hard to really tell the difference between those. But you can do them to compare relative to each other. Like you could compare Alaska versus Oregon, number 10. You can see the difference in that. Who uses statistics? Statistical techniques are used by marketing people, accounting people, quality control people. Uh, for example, marketing may want to know what the number of customers that prefer a certain brand. Accounting has to analyze costs, come up with statistical information about cost. Quality control uses statistics to monitor processes. Consumers use information. For example, if you see something that says 9 out of 10 customers prefer this brand over the other. Obviously, professional sports people use statistics. Hospital administrators use it for measuring quality or levels of performance. Educators use them in testing. Politicians obviously use them to keep up with the number of people that are going to vote for them or the number of people that approve of them. Physicians also use statistics for determining treatments that they use. There are two types of statistics, descriptive statistics and inferential statistics. Let's talk about descriptive statistics first. And notice when I read this definition, you'll see some more of those ing words. Descriptive statistics, we're basically trying to describe data. So these are methods of organizing, summarizing, and presenting data in an informative way. So we're just sort of taking the information and organizing and presenting it. We're just describing something. So look at example 2 on the screen. According to the Bureau of Labor Statistics, the average hourly earnings of production workers was $17.90 for April 2008. That's a statistic. Inferential statistics is when you actually use the statistics to make a decision about a population based on a sample. So let me read the definition and then we'll talk about population and samples. Inferential statistics is a decision, estimate, prediction, or a generalization about a population based on a sample. So in statistics, we use the words population and sample. They have a particular meaning. Population would be the entire group. A sample is a portion. So everyone enrolled in our statistics class, that would be everyone taking Business 216 this trimester would be the population. But if I only took a certain part of that group, maybe everybody sitting on the front row, that would be a part of the population. We would call that a sample. So basically in inferential statistics, we take our information that we get from a sample and we try to make an inference about the population. A population is a collection of all possible individuals, objects, or measurements of interest, and a sample is a portion or part of the population of interest. So if you're looking at this screen, in the big box you see all the items. Let's suppose that those are all the cars. That's considered the population. So that might be all the cars in our parking lot. But notice that on the right side, they've taken some of those cars or a portion of those cars. They've taken 6 of those and they're calling that a sample. So a population is all and sample is a portion. Why do you take a sample instead of taking every member of the population? If we wanted to do a survey of everyone in the United States, that would cost a lot of money. It would also take a lot of time. Sometimes we take a sample if we're testing items. For example, if you were making hand grenades, you would not be able to test every single hand grenade, so you would have to take a sample of those. If you tested every one of them, you would have none left to sell. Or if you wanted to test the length of time that a light bulb lasts, you would not be able to test every light bulb to see how long it lasts because you wouldn't have any left to sell. Sometimes it's not possible to test or inspect all members of a population being studied. For example, if I want to know the percentage of mosquitoes that have West Nile virus, I will not be able to catch every mosquito and test them. It's just physically impossible to do that. There are two types of variables. There are qualitative variables and there are quantitative variables. A qualitative variable is something that is non-numeric, meaning it's not a number. An example of that would be your hair color, your eye color, the state in which you were born. A quantitative variable is a numeric variable. It is a number. So examples are how much money you make, your grade on the test, how much you weigh, your height, how far you drive to school. And a good example is how long you spend studying. That would be a quantitative variable. Now you're ready to take the quiz on qualitative and quantitative variables.